If we are asked to find the values in the simultaneous equation by using the matrix method, this is how it is done. We have three different equations here, and we name this as equation 1, equation 2, equation 3. So you are supposed to change these three equations into matrix. So the coefficients of the variables x, y, and z will be written in the matrix form. Starting with the coefficient of the x, and the coefficient of the y, and the coefficient of the z. Now, these are the coefficients of the variables. We have their constant also there. Alright, let's label our matrices. This first matrix, I'll name it A. This one, I'll name it X. And this one, I'll name it B. So we are supposed to find the variables X, Y, and Z. So we are going to put this into simple equation by making X the matrix established. So we have X being equal to. So if you want to make X to start alone, you need to take the matrix A to the side of matrix B. And that gives you A inverse by B. So in this case, we are going to find, before we can get the x, we need to find the A inverse multiplied by this matrix B, then our x will be known. That will be the x, y, and z. So let's focus on the A inverse. Alright, so A inverse, or whenever you're finding inverse of any matrix, the formula goes like this. We have 1 out of the determinant of that matrix, and that matrix is A, so the determinant of A, multiplied by the adjoint of that matrix, and we have the adjoint of A. So over here, we are supposed to find the determinant and the adjoint to get our inverse of the matrix. So the determinant of A is equal to, this time, I'm going to use the minor and the cofactor strategy to do this. So we have this matrix as matrix A. So the labeling says that, the cofactor labeling says that. So the first should be positive, second should be negative, then it goes like that. So we are using only the first row to get our determinant. So we stand on this number. So when we stand on this number, we delete each column and each row. So leaving this matrix in the middle. And this will give you the 2 by 2 matrix. But the number we use is 1 and the cofactor is positive. So we have positive 1. Then we write a 2 by 2 matrix. That will give you negative 3, 1, 1, 2. Then we have the next, so this is done, they come to this side. So we are going to delete each column and each row in this form. So leaving this 2 by 2 matrix. So 2, 2, and 1, 2. And the cofactor is negative with the 1. So we have negative 1. And the 2 by 2 matrix is 2, 2, 1, 2. So we come to the next number on the first row, negative 1. So we delete its column and each row, leaving this 2 by 2 matrix. The cofactor is positive, but the number itself is negative, so we conquer the cofactor, which is positive to negative, and it's negative 1. And the 2 by 2 matrix will be 2, 2, negative 3, 1. So in this case, you are supposed to find the determinant of each 2 by 2 matrix. So we have this one multiplying whatever we get for the determinant of that matrix. So the left diagonal will multiply, and I'm going to get negative 6. So the minus the product of the right diagonal, that will give you 1. Continue. We have the product of this is 4, minus the product of this is 2. The product of this is 2, minus the product of this is negative 6. But we already have negative 8, so to change to positive 6. To find the values in the brackets, we have 1 multiplying negative 7. This will give you 2, and this will give you 8. Finally, we have to find, this time this will give you negative 7, this time this will give you negative 2, this time this will give you negative 8. So our determinant will become negative 17. So this is our determinant. All right. So we are supposed to find the adjoint of A. So let me create a space here. So the determinant of A is negative 17. So I need to create a space for the adjoint. All right. So for the adjoint, we're not going to use the minor and the cofactor strategy. That will be very long. So I choose my strategy as it was given in the previous video. So let's follow that strategy and get our adjoint of this 3 by 3 matrix. So we repeat writing this matrix. All right. Now we're going to find the adjoint of this 3 by 3 matrix. So the strategy says that we should repeat the first two rows and also repeat the first two columns. Then we delete the first row and the first column. So let's go. This. We have the first two rows is the one we have to do first. So first two rows is 1, 1, negative 1, and 2, negative 3, 1. So after writing the first two rows, then we write the first two columns. And all this is the first column, this is the second column. So we write it here 1, 2, 2, 1, 2. And 1, negative 3, 1, 1, negative 3. So I'm going to delete the first row and the first column. First row, first column, deleted. So you can see we have 4 by 4 matrix in the middle. So we are going to write it as a new matrix. So let's take it as our new matrix. And this will give you negative 3, 1, 1, negative 3. 1, 2, negative 1, 1. 2, 2, 1, 2. Negative 3, 1, 1, negative 3. So this is our new 4 by 4 matrix. So from there we can get our adjoint. So let me proceed and see adjoint of A will be this. So let's see the strategy the adjoint can be found. Now there is our 4 by 4 matrix here, and we need to create 2 by 2 matrix from this 4 by 4 matrix and write the results over there. Then we get our adjoint. So we have this column and this row. So whatever we do the 2 by 2 matrix, determinant of the 2 by 2 matrix that we do here at the column side, we will not write the answers at the column side, but we instead write the answers at the row side. This is just to prevent afterwards transpose. So we don't want to do this transpose, we are going to do it straightforward. So this is what you do for the shortcut to get your answer so easy. So let's go. We have determinant of this 2 by 2 matrix. So we have negative 3 times this, that will give you negative 6 minus, and this times this will give you. So we have our negative 7 as our first number. Then we have this 2 by 2 matrix. So negative 1 times negative 1, then 2 times. So we have this as our second number. Then this 2 by 2 matrix. So we have 1. Then this and this will give you positive. So positive 3. And I'm going to have positive 3, and that will give you negative 2. Alright. So you can see that the answer from the 2 by 2 matrix at the column side have been written at the row side. Alright, so that is the strategy. So let's continue. We have the determinant of these 2 by 2 matrix. This and this will give you 2, and this will give you 4. And we are going to get minus 2. Determinant of this will give you 2, this will give you minus 2. So minus 2 will give you positive, and you are going to get 4. Determinant of this and this will give you minus 2, this and this will give you 1, and get negative 3. So let's finish our last row over there. This and this, so this and this will give you 2, this and this will give you negative 6. So negative 6, we have a negative already there, so we have our 8. So this and this, so we have 2 minus 1, and that will give you minus 1 here. This and this. So we have, this will give you negative 3, this will give you 2, and we have negative 5. So with this strategy, our adjoint is now found. Using this strategy, instead of creating all the 2 by 2 matrix from each row and each column, that's using the minor and the cofactor strategy, getting all the determinants and transpose the determinants again to get the arguments. This is very simple. So mathematics teachers out there, let's adapt this. This is very easy for students to understand. All right, now let's go about the inverse, the inverse. So creating a space. So you can see I have my determinants here, I have my arguments here. So my A inverse is given by the formula 1 over the determinant and is negative 17 multiplied by the adjunct, and adjunct is there. Alright, so for us to find x, we need to take this formula. So we said that x is equal to A inverse multiplied by B, that is B. So A inverse is this multiplied by B. So I'm going to write the A inverse is all about this. So we have negative, so negative. Okay, we have 8. So you can see the A inverse is there multiplied by the matrix B, and this is the matrix B, 0, 1, 7. So we are going to this. So we are going to first write 1 over negative 17. Then I'm going to multiply this matrix against this matrix. Alright, so we'll multiply the first two against this other matrix. Then we fill out all the gaps inside it. So starting from this, so negative 7 times 0, 0. Then negative 3 times 1, we do minus 3. Negative 2 times 2 is minus 4. Negative 2 times 0, 4 times 1 is plus 4. And this time this will give you minus 21. We have this time this will give you 0. This time this will give you minus 1. And this time this will give you minus 35. Alright. So in this case, we are going to sum everything up here. So we have 1 over negative 17. Then what is the result for the first row? This will give you negative 17. Then over here too, it will give you negative 17. And over here will give you negative 34. Alright, so let's do this and this. So negative 34. Now we have to use this to multiply each term here, and we are going to get negative 17 times this. We have negative 17 over negative 17. Then negative 17 over negative 17. And the last one, negative 34 over negative 17. So our x is equal to, this will give you 1, this will give you 1, this will give you 2. Now remember x was labeled as this, so it is also compared to x, y, and z. So we can say that therefore x equal to 1, y equal to 1, and z equal to 2. Yes. So this is the strategy on how to use the matrix method to solve simultaneous equation involving 3 variables. Thank you very much for watching. I hope you learned from this video. Don't forget to follow, like, comment to my video, and also visit my YouTube channel at GH Mathematics Doctor and subscribe to my channel.